Picture this: a universe so vast and endless that it could house billions of stars, each potentially orbited by planets we've yet to discover. Now imagine that somewhere out there, beyond the twinkling lights of our night sky, there might be worlds not so different from our own worlds that could cradle life in ways we've only dreamed of. This isn't science fiction. This is the thrilling reality of our search for extraterrestrial life. Today, we're diving into the cosmos to uncover 20 planets that could support life beyond Earth. From rocky terrains to water-covered surfaces, these distant worlds hold secrets that could reshape our understanding of existence itself. The universe is unimaginably vast, and the possibility of finding another habitable planet is both humbling and exhilarating. So, are you ready to explore these extraordinary discoveries and the mysteries they hold? Strap in, because this journey through the stars is about to ignite your curiosity like never before. Now, let's turn our attention to Proxima Centauri b, a planet that has captured the imagination of astronomers and space enthusiasts alike. Located just 4.24 light-years away, this world is the closest known exoplanet to Earth, making it a prime candidate in the search for life beyond our solar system. Proxima Centauri b orbits within the habitable zone of its star, where temperatures could allow for the presence of liquid water, a key ingredient for life as we know it. However, this planet isn't without its challenges. It's tidally locked, meaning one side perpetually faces its star while the other remains in eternal darkness. This could create extreme temperature differences, complicating the potential for a stable environment. Adding to the complexity, the star it orbits, Proxima Centauri, is known for its intense stellar flares, which could bombard the planet with harmful radiation. Despite these hurdles, Proxima Centauri b remains a fascinating subject of study, offering a glimpse into the possibilities and challenges of life in another star system. As we explore further, let's consider the intriguing possibilities surrounding the atmosphere of Proxima Centauri b. Scientists have speculated that, despite its challenges, this planet might possess an atmosphere capable of supporting life. One theory suggests that if Proxima Centauri b has a thick atmosphere, it could help distribute heat more evenly, mitigating the extreme temperature differences caused by its tidal locking. This could create more hospitable conditions on both its day and night sides. Another possibility is that the atmosphere could contain greenhouse gases like carbon dioxide, which might trap heat and maintain warmer temperatures, even in areas receiving less direct starlight. However, the intense stellar flares from Proxima Centauri pose a significant threat. These flares could strip away the planet's atmosphere over time, leaving it exposed to harmful radiation. Despite these risks, some researchers believe that if Proxima Centauri b has a strong magnetic field, it could shield the planet from these flares and preserve its atmosphere. While the exact composition of this atmosphere remains a mystery, the potential for it to harbor life continues to fuel scientific curiosity. As we study this distant world, we're learning not only about its possibilities, but also about the resilience life might need to thrive in such extreme environments. Now, let's turn our attention to another fascinating world, TRAPPIST-1e. This planet stands out for its Earth-like size and its location within the remarkable TRAPPIST-1 system, which hosts 7 known planets. TRAPPIST-1e is particularly intriguing because of its rocky composition, which closely resembles Earth's own structure. This similarity raises questions about whether it could also support similar geological processes and potentially even life. One of the most exciting possibilities is the presence of liquid water on its surface, a key ingredient for life as we know it. The planet lies within its star's habitable zone, where temperatures could allow water to exist in a liquid state. Scientists have been particularly interested in the potential for TRAPPIST-1e to maintain a stable climate, given its proximity to its ultra-cool dwarf star. While the star itself is much cooler than our Sun, Its longevity and stability could provide a consistent energy source for billions of years. This makes TRAPPIST-1e a prime candidate for further study in the search for habitable worlds. As we continue to explore this system, the secrets it holds could bring us closer to answering one of humanity's oldest questions: are we alone in the universe? Now let's take a step back and explore the bigger picture of the TRAPPIST-1 system as a whole. This remarkable system is home to 7 Earth-sized planets, each with its own unique characteristics. What makes TRAPPIST-1 so special is the way these planets orbit their star in a tightly packed formation. Imagine a solar system where the planets are so close together that standing on one might allow you to see another in the sky, much like our moon. This proximity raises fascinating questions about how these worlds interact with each other and whether they could share resources or even life. 3 of these planets, TRAPPIST-1e, F, and G, are located within the habitable zone, where temperatures could allow liquid water to exist. This is a rare and exciting discovery, as it increases the odds of finding environments capable of supporting life. Scientists are also intrigued by the possibility of tidal forces influencing these planets, potentially creating geological activity or even subsurface oceans. The TRAPPIST-1 system offers a unique laboratory for studying how Earth-sized planets form and evolve, and it could hold vital clues about the potential for life beyond our solar system. As we continue to study this system, each new discovery brings us closer to understanding the diversity of worlds in our universe and what it takes for a planet to truly be habitable. Shifting our gaze to a more distant yet intriguing world, let's turn our attention to Kepler 452b, often referred to as Earth's cousin. This planet, located a staggering 1,400 light-years away, has captured the imagination of scientists and space enthusiasts alike. What makes Kepler 452b so fascinating is its striking resemblance to Earth in both size and orbit. It's about 60% larger than our planet and orbits its star at a distance that places it firmly within the habitable zone where liquid water could potentially exist. Its host star is remarkably similar to our Sun, sharing characteristics like temperature and size, which further fuels speculation about its potential to support life. However, studying a world so far away comes with significant challenges. The vast distance makes it difficult to gather detailed data about its atmosphere, surface conditions, or even the presence of water. Despite these obstacles, Kepler 452b remains a key focus in the search for habitable planets, offering a tantalizing glimpse into what Earth-like worlds might look like in other corners of the galaxy. Its discovery reminds us that while the universe is vast, the potential for finding familiar environments is far from impossible. Now, let's take a moment to appreciate the incredible tool that made the discovery of Kepler 452b possible, the Kepler Space Telescope. Launched in 2009, this groundbreaking mission was specifically designed to search for planets beyond our solar system. Over its 9-year mission, Kepler observed over 150,000 stars in a small patch of sky, meticulously measuring their brightness to detect the telltale dips caused by orbiting planets. This method, known as the transit technique, allowed Kepler to identify thousands of exoplanets, revolutionizing our understanding of the universe. Among its many discoveries, Kepler 452b stands out as a prime example of the telescope's ability to find Earth-like worlds. Beyond individual planets, Kepler's data revealed that planets are far more common than we once thought, with many residing in their stars' habitable zones. The mission also highlighted the diversity of planetary systems, from compact multi-planet arrangements to solitary giants orbiting distant stars. Although the Kepler mission officially ended in 2018, its legacy continues to shape the field of exoplanet research. It has paved the way for future telescopes, equipping scientists with the knowledge and tools to keep searching for potentially habitable worlds. Kepler's contributions remind us that every discovery, no matter how distant, brings us one step closer to answering the profound question, are we alone in the universe? Turning our gaze to another intriguing world, let's explore LHS 1140b. This fascinating planet orbits within the habitable zone of a red dwarf star, a region where conditions might allow for the presence of liquid water, a key ingredient for life as we know it. What makes LHS 1140b particularly compelling is its dense atmosphere, which scientists believe could play a crucial role in shielding the planet from harmful radiation emitted by its host star. Red dwarfs are known for their intense and frequent stellar flares, which can strip away a planet's atmosphere or make it inhospitable. However, the thick atmosphere of LHS 1140b might offer a protective barrier, potentially creating a stable environment where life could thrive. Its location in the habitable zone, combined with this protective layer, makes it one of the most promising candidates for further study in the search for extraterrestrial life. As we continue to uncover the secrets of distant worlds, LHS 1140b stands out as a testament to the resilience and diversity of planets in the universe. And with each discovery, we inch closer to understanding whether we are truly alone among the stars. Now, let's take a closer look at the broader picture of planets orbiting red dwarf stars. These small, dim stars make up the majority of stars in our galaxy, and their long lifespans, often lasting trillions of years, make them intriguing hosts for potentially habitable planets. Red dwarfs burn their fuel slowly, giving planets in their habitable zones an extraordinary amount of time to develop and sustain life. However, this potential comes with significant challenges. Many planets orbiting red dwarfs are tidally locked, meaning one side of the planet perpetually faces the star while the other remains in eternal darkness. This creates extreme temperature differences that could make it difficult for life to thrive. Additionally, red dwarfs are prone to intense stellar flares, which can bombard nearby planets with harmful radiation. Despite these hurdles, planets like LHS 1140b offer hope. Their dense atmospheres and potential protective shields suggest that life might find a way to persist even in these harsh environments. Understanding the habitability of red dwarf systems not only expands our search for life beyond Earth, but also challenges us to rethink what conditions might truly support it. As we continue exploring these distant worlds, we uncover new possibilities and deepen our appreciation for the resilience of life in the universe. Turning our gaze to another fascinating world, Gliese 667cc stands out as a remarkable contender in the search for life beyond Earth. This planet is located in a triple star system, a rare and intriguing setup where three stars orbit one another, creating a dynamic celestial environment. Gliese 667cc circles one of these stars, a red dwarf, and sits within its habitable zone where temperatures could allow for the presence of liquid water. What makes this planet particularly intriguing is its Earth-like mass, suggesting a rocky composition similar to our own world. The unique conditions of its star system add another layer of complexity to the story. With three stars in the mix, the planet experiences a blend of gravitational forces and varying light levels, which could create unusual but potentially stable climate patterns. While the challenges of such a system are significant, including the possibility of irregular orbits and exposure to multiple sources of stellar radiation, Gliese 667cc remains a compelling example of how life might adapt to extraordinary conditions. As we continue to study planets like this one, we gain a deeper understanding of the diverse environments that could serve as homes for life in the cosmos. Shifting our focus to the broader implications of multi-star systems, we find a cosmic ballet of gravitational forces and intricate orbital dynamics. Planets like Gliese 667cc, nestled within such systems, face unique challenges and opportunities. In a triple star setup, the gravitational pull of multiple stars can create complex and sometimes unpredictable orbits. This could lead to irregular seasons or extreme temperature variations, making it harder for a stable climate to form. However, some scientists suggest that under certain conditions, these systems might actually foster stable environments. For instance, if a planet orbits far enough from the stars, it could avoid the most disruptive gravitational effects, allowing for a more consistent climate. Additionally, the presence of multiple stars could provide a steady source of energy, potentially mitigating the risk of a planet becoming too cold. On the flip side, the increased radiation from multiple stars could pose a threat to any potential life forms. Despite these challenges, multi-star systems open up fascinating possibilities for habitability, reminding us of the incredible diversity of planetary environments in the universe. As we continue to explore these systems, we uncover new insights into how life might adapt to even the most complex cosmic conditions. Now, let's turn our attention to Kepler 22b, a planet that holds a special place in the history of exoplanet discovery. Identified by the Kepler Space Telescope, this world was one of the very first planets found within its star's habitable zone, sparking excitement about its potential to support life. Kepler 22b is about 2.4 times the size of Earth, making it significantly larger but still within the range of what scientists consider potentially habitable. Its orbit around its star takes roughly 290 Earth days, placing it in a region where temperatures could allow for liquid water to exist. What's particularly intriguing about Kepler 22b is the possibility that it might be an ocean planet with vast stretches of water covering its surface. While we don't yet have definitive proof of this, the idea of a water world opens up fascinating possibilities for life, as oceans could provide a stable environment for complex ecosystems to develop. However, its larger size also raises questions about the nature of its atmosphere and surface conditions, which could differ greatly from those on Earth. Kepler 22b serves as a reminder of the incredible diversity of planets out there and continues to inspire our search for worlds that might harbor life beyond our own. Moving forward, let's explore the fascinating concept of water worlds, planets that may be entirely covered by vast oceans. These intriguing celestial bodies, like Kepler 22b, challenge our understanding of what a habitable planet might look like. Imagine a planet where land is virtually non-existent and the entire surface is dominated by deep, endless oceans. Such worlds could have profound implications for the potential of life, as water is essential for the complex chemistry that life relies on. On a water world, the oceans could act as a stable medium, regulating temperatures and providing a habitat for marine organisms, much like Earth's oceans. However, the absence of land raises questions about how life might develop. Without continents, nutrients that are typically washed into the oceans from rivers would be scarce, potentially limiting the diversity of ecosystems. Additionally, the immense pressure at the bottom of these deep oceans could make life challenging for organisms similar to those on Earth. Yet, the possibility of life adapting to such extreme environments cannot be ruled out. Scientists hypothesize that hydrothermal vents, which are found in Earth's oceans and support unique ecosystems, could also exist on water worlds, providing energy and nutrients for life. As we continue to study planets like Kepler 22b, the idea of water worlds expands our imagination and reminds us that life may thrive in ways we have yet to discover. The search for these ocean-covered planets is not just about finding water, but about uncovering the incredible variety of environments where life could potentially exist in the universe. Now, let's turn our attention to Ross 128b, a planet that stands out not just for its potential habitability, but also for its relatively close proximity to Earth, located just 11 light-years away. Orbiting a red dwarf star, Ross 128b benefits from a quieter stellar environment compared to many other red dwarf systems. This calmness is crucial because red dwarf stars are often known for their intense stellar activity, such as powerful flares that can bombard nearby planets with harmful radiation. However, Ross 128b's star is remarkably stable, which significantly reduces this risk. This stability could make the planet's surface conditions more favorable for life, as it would be less exposed to the extreme bursts of radiation that could strip away atmospheres or sterilize surfaces. Additionally, Ross 128b resides within its star's habitable zone, where liquid water could potentially exist. What's particularly intriguing is that this planet orbits closer to its star than Earth does to the Sun, completing an orbit in just under 10 Earth days. Despite this close distance, the cooler nature of its red dwarf star means Ross 128b could still maintain a moderate temperature range. Scientists are particularly interested in this planet because its relatively calm environment and proximity to Earth make it a prime target for future observations, including searches for biosignatures. The study of Ross 128b not only brings us closer to understanding the habitability of red dwarf systems, but also reminds us that even in the quieter corners of the universe, life might find a way to thrive. As we continue to explore worlds like this one, the possibilities for discovering life beyond our solar system grow ever more exciting. Shifting our focus to the hunt for signs of life, scientists employ a variety of cutting-edge techniques to detect biosignatures on planets like Ross 128b. One of the most promising methods involves analyzing the planet's atmosphere through a process called spectroscopy. When light from the planet's host star passes through its atmosphere, certain wavelengths are absorbed by the gases present. By studying these absorption patterns, researchers can identify specific molecules like oxygen, methane, or carbon dioxide, which might indicate biological activity. For Ross 128b, this approach is particularly exciting because its calm red dwarf star creates a stable environment, making it easier to detect subtle atmospheric signals. Another technique involves searching for chemical imbalances in the atmosphere that could hint at life. For example, the simultaneous presence of oxygen and methane is considered a strong biosignature because these gases typically react with each other and disappear unless replenished by some ongoing process like photosynthesis. Future telescopes such as the James Webb Space Telescope and upcoming ground-based observatories will play a crucial role in this search, providing the sensitivity needed to study distant atmospheres in detail. Additionally, scientists are exploring indirect signs of life, such as the presence of liquid water or unusual surface features. On Ross 128b, the potential for liquid water and its moderate temperature range make it a prime candidate for these investigations. By combining multiple methods, atmospheric analysis, surface observations, and even the search for technosignatures like artificial lights or structures, researchers hope to build a comprehensive picture of whether life exists beyond Earth. Each discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? As we continue to refine these techniques and explore worlds like Ross 128b, the search for biosignatures remains a thrilling and transformative pursuit. Moving on to another intriguing world, let's take a closer look at Kepler 62f. This planet, discovered by the Kepler Space Telescope, has captured significant attention due to its Earth-like size and its position within the habitable zone of its star. Located roughly 1,200 light-years away, Kepler 62f orbits a star slightly cooler and smaller than our Sun, but its placement in the habitable zone raises the exciting possibility of liquid water on its surface. The presence of water, as we know, is a crucial ingredient for life as we understand it, making this planet a fascinating subject for further study. However, studying Kepler 62f comes with its own set of challenges. Its immense distance from Earth makes it difficult to gather detailed information about its atmosphere or surface conditions. Current telescopes can detect the planet's existence and some basic characteristics, like its size and orbit, but uncovering finer details requires more advanced technology. Future missions and instruments such as the James Webb Space Telescope may provide deeper insights, potentially revealing whether Kepler 62f has an atmosphere capable of supporting life or even signs of liquid water. The planet's size, about 1.4 times that of Earth, suggests it could be a rocky world similar to our own. If it does indeed have liquid water, it could potentially host oceans, rivers, or even continents, sparking imaginations about what life might look like there. Yet, the mysteries surrounding Kepler 62f remind us of the vastness of space and the challenges of exploring distant worlds. As we continue to push the boundaries of our technology, planets like Kepler 62f keep us hopeful and curious about the possibilities that lie beyond our solar system. Now, let's delve into a key concept that often determines whether a planet like Kepler 62f could support life: the habitable zone, also known as the Goldilocks zone. This term might sound whimsical, but it's rooted in a critical scientific idea. The habitable zone refers to the region around a star where conditions are just right, not too hot and not too cold, for liquid water to exist on a planet's surface. Water is essential for life as we know it, making this zone a primary focus in the search for habitable worlds. The name Goldilocks Zone comes from the famous fairy tale where Goldilocks finds the porridge that's just right. Similarly, planets in this zone are at the perfect distance from their star to maintain temperatures that allow water to remain in liquid form. Too close and the heat would evaporate it, too far and it would freeze. This balance is crucial because liquid water acts as a solvent, facilitating the chemical reactions necessary for life. However, the habitable zone isn't a fixed or uniform area. It varies depending on the type and size of the star. For example, smaller, cooler stars like red dwarfs have habitable zones much closer to them, while larger, hotter stars have zones that are farther out. Additionally, other factors such as a planet's atmosphere can influence whether it remains habitable even if it's within this zone. A thick atmosphere can trap heat, potentially extending the habitable range, while a thin one might not retain enough warmth. Understanding the Goldilocks zone helps scientists narrow down the vast number of exoplanets discovered and focus on those most likely to support life. It's a foundational concept in astrobiology, guiding missions like the Kepler Space Telescope and the James Webb Space Telescope as they search for Earth-like worlds. By studying planets within this zone, researchers hope to uncover clues about the potential for life beyond our solar system, bringing us one step closer to answering the age-old question, are we alone in the universe? Now, let's turn our attention to HD 40307G, a fascinating world classified as a super-Earth. This means it's larger and more massive than our own planet, but smaller than gas giants like Neptune. Located roughly 42 light-years away in the constellation Pictor, HD 40307G orbits within its star's habitable zone, putting it in the coveted sweet spot where liquid water could potentially exist. What makes this planet particularly intriguing is its potential for a thick atmosphere. A dense atmosphere could play a crucial role in retaining heat, creating a stable environment that might support life. Even if the planet doesn't receive as much warmth from its star as Earth does from the Sun, a thick atmosphere could act like a blanket, trapping heat and maintaining temperatures suitable for liquid water. This phenomenon, known as the greenhouse effect, is something we see on Earth and could be a key factor in making HD 40307G habitable. However, there are still many unknowns. The composition of its atmosphere, if it exists, remains a mystery. Scientists are eager to determine whether it contains essential gases like oxygen, carbon dioxide, or methane, which could hint at the presence of life. The challenges of studying such distant worlds are immense, but advancements in technology like the James Webb Space Telescope are bringing us closer to uncovering these secrets. As we continue to explore HD 40307G, It serves as a reminder of the diverse and complex possibilities that exist beyond our solar system. Now, let's take a closer look at what makes super-Earth such compelling subjects in the search for life beyond our solar system. These planets, which are larger and more massive than Earth but smaller than gas giants, represent a unique category in the exoplanet family. Their size and mass could give them distinct advantages when it comes to habitability. For instance, a super-Earth's stronger gravity might help it retain a thicker atmosphere, which could be crucial for maintaining stable temperatures and protecting against harmful radiation. However, the very characteristics that make super-Earths intriguing also present challenges. Their larger size and mass could lead to intense surface pressures, making it difficult for life as we know it to thrive. Additionally, the composition of their atmospheres remains largely unknown. While some super-Earths might have atmospheres rich in nitrogen and oxygen, others could be dominated by less hospitable gases like carbon dioxide or methane. This diversity makes it harder for scientists to generalize about their potential for life. Another challenge lies in understanding their surfaces. Without direct observation, we rely on indirect methods, such as analyzing the light that passes through their atmospheres or studying their gravitational effects on their host stars. These techniques can provide clues, but they often leave us with more questions than answers. For example, is a super-Earth surface rocky like Earth's, or is it covered in vast oceans or even molten lava? Despite these uncertainties, super-Earths like HD 40307G offer a tantalizing glimpse into the variety of worlds that could exist beyond our solar system. They remind us that habitability is a complex puzzle, shaped by countless factors ranging from atmospheric composition to geological activity. As our technology advances, we're inching closer to unraveling these mysteries, bringing us one step closer to answering the ultimate question: are we alone in the universe? Shifting our gaze to another intriguing world, let's explore Tau Ceti e, a planet located approximately 12 light-years from Earth. This relatively close distance makes it one of the more accessible targets for future exploration and study. Tau Ceti e orbits a star similar to our Sun, raising hopes that it could be a promising candidate in the search for life. One of the most exciting possibilities is the potential for liquid water on its surface, a key ingredient for habitability as we know it. However, Tau Ceti e's position within its star's habitable zone is a topic of debate among astronomers. Some calculations suggest it sits just inside the inner edge of the zone, meaning it could be too hot to support liquid water. Others argue that its exact location remains uncertain, leaving room for the possibility of a more temperate environment. This controversy highlights the complexities of determining habitability, even for planets that seem promising at first glance. Adding to the intrigue is Tau Ceti e's mass, which is estimated to be at least 4 times that of Earth. This places it in the super-Earth category, raising questions about its atmosphere and surface conditions. Could it have a thick atmosphere capable of retaining heat and shielding it from harmful radiation? Or might its surface be too extreme for life to take hold? As we continue to study Tau Ceti e, it serves as a reminder of the challenges and excitement in the search for habitable worlds. Its proximity to Earth makes it a prime target for future observations, offering the tantalizing possibility of uncovering more about its potential to support life. Turning our attention to the wider Tau Ceti system, we uncover a fascinating region of space that shares some striking similarities with our own solar system. Tau Ceti, the system's central star, is a G-type main sequence star, much like our Sun, though slightly smaller and dimmer. This similarity fuels speculation that the system could harbor conditions conducive to life, especially given the presence of multiple planets orbiting within its vicinity. One of the most notable features of the Tau Ceti system is its relatively stable environment. Unlike other stars that emit intense bursts of radiation, Tau Ceti is considered relatively calm, reducing the risk of harmful stellar activity for its planets. This stability increases the likelihood that any planets within its habitable zone could maintain conditions favorable for life over long periods. Within this system, Tau Ceti E is not the only planet of interest. Another intriguing world is Tau Ceti F, located farther out in the system. While Tau Ceti F's position suggests it might be too cold for liquid water, some models indicate that a thick atmosphere could potentially trap enough heat to create a habitable environment. These two planets, along with others in the system, highlight the diverse possibilities for habitability in a single stellar neighborhood. What makes the Tau Ceti system particularly compelling is its proximity to Earth just 12 light-years away. This closeness places it within reach of future observational technologies, such as advanced telescopes and even potential interstellar missions. Scientists are especially interested in studying its planets for biosignatures, chemical markers that could indicate the presence of life. As we explore the Tau Ceti system, we're reminded of the incredible diversity of planetary environments in our galaxy. From its sun-like star to its potentially habitable worlds, this system offers a tantalizing glimpse into the possibilities of life beyond Earth. It stands as a testament to the ongoing quest to uncover the mysteries of the cosmos and the potential for finding other worlds that could one day call us neighbor. As we bring this journey through the cosmos to a close, it's worth reflecting on the remarkable diversity of the 20 planets we've explored. From the nearby Proxima Centauri b to the distant Kepler 452b, each world offers a unique glimpse into the possibilities of life beyond Earth. Some are rocky, Earth-like planets nestled in the habitable zones of their stars, while others are water worlds or super-Earths with thick atmospheres. These discoveries remind us that the universe is teeming with potential habitats, each with its own story to tell. What's truly inspiring is how far we've come in our search for life. Just a few decades ago, exoplanets were a matter of speculation. Today, thanks to missions like Kepler and advancements in telescopic technology, we've identified thousands of these distant worlds, with more being discovered every year. The quest to find life beyond Earth is no longer a dream. It's a scientific endeavor driven by curiosity, innovation, and the hope of answering one of humanity's oldest questions: are we alone? But this is just the beginning. As we look to the future, new missions and instruments like the James Webb Space Telescope promise to deepen our understanding of these distant worlds. With each discovery, we're not just learning about other planets, we're learning about our place in the universe. Every potentially habitable world is a reminder of how vast and diverse the cosmos truly is, and how much we have yet to explore. So, as we conclude this exploration, let's carry that sense of curiosity with us. Whether you're an avid space enthusiast or someone just beginning to ponder the mysteries of the universe, there's always more to discover. Keep looking up, stay curious, and remember, the search for life beyond Earth is a journey that unites us all. If you've enjoyed this journey through the stars, don't forget to like this video, subscribe, and hit the notification bell to stay updated on our latest explorations. Together, let's keep uncovering the wonders of the cosmos. Until next time, keep dreaming, keep exploring, and keep wondering about the endless possibilities that lie beyond our world.